Hi guys, this is Kira here with another No Sci Science video. Today we're going to be looking at the physical science labs for the college prep physical science class, and we're going to be looking at the physical science B labs. So, if you didn't watch the physical science A lab video, you may have missed this part about the physical science lab breakdown, so I'm going to briefly run through it again. The physical science lab breakdown, which you can access through this link in this PowerPoint or find it in the physical science folder, is essentially a breakdown of which activities are going to be graded in the unit, the time it takes to complete them, the page number or activity number of them, and how much teacher involvement is needing. NT being no teacher involvement needing, 1 being a very low teacher involvement, and 3 being a very high teacher involvement. So it's really up to you, how much involvement obviously you want to have, but it just kind of gives you a very generalized breakdown of what to expect for each of the labs. This is representing physical science A, but there is a tab for physical science B. So now we're going to go through some of the labs and how you're going to do them for physical science B. The first lab that we're going to talk about is Activity 2. This is a non-graded lab, and this lab is looking at distance and displacement. And essentially, students are just trying to get more practice with it. Each student is going to need a ruler, so you don't really have anything to order or have to worry about getting from the kit. And the teacher can actually model part of it, and then the students can complete the rest. So sometimes they get a little bit mixed up with maybe what they're supposed to be doing. So just having that teacher model it first kind of helps them figure out what they're supposed to be doing. Now, the next activity is Activity 9. This is a graded lab. Now, this is another online lab. It is a PhET simulation, and if you watched the Physical Science A video, you heard me talk a little bit about this. PhET simulations do not work on Chromebooks, so you need to make sure that you get access to an actual computer. This is a good one to do as kind of a group demo, again, because usually the teacher is the only one with the actual laptop. The thing that you're doing is that you're looking at position versus time, velocity versus time, and acceleration versus time using this little tool right here. Okay, it's a pretty neat little simulation. The kids do enjoy it. You can even have them maybe come up to the board and do parts of it for you, but again, it may be a little tricky to have every student have this simulation if you're doing this direct instruction. Okay, if you don't want to do that, there is an alternative. You can find this in the physical science folder, or again, you can access it via this PowerPoint by clicking on this link right here. It's up to you. Check it out, check both things out, and see which one you'd rather do. The next thing is Activity 13, and this is a non-graded lab, but I think an interesting one. So essentially what students are looking at is friction, and they're experimenting with how surface texture affects the force of friction. So you need a spring scale, some different shoes, some tape, some paper clips. So you do have to collect a few different things for this. Again, this is another good one to kind of do as a group demo and not as an individual activity. But again, it depends on your class, and students are going to kind of look at the friction on the shoes and things like that. So it's a pretty neat little one, even though it's non-graded. This is another non-graded lab. This one's very straightforward. We're looking at Newton's first law, inertia, by looking at a penny. Now, this is a very common Newton laws activity where they're placing a card on top of a glass and putting a penny, and essentially they're going to be flicking it. And there's tons of sample videos of this on the internet. It's very, very straightforward, and it's a quick, easy little lab that you can do even though it's non-graded. Again, you could even do this as a demo if you're just trying to show the students something really quick. Lastly is Activity 23 here, and this is a graded lab. So this is ideally showing Newton's third law, which is a car that students have made, essentially of cardboard, being powered by the force of a balloon. Now, the only issue with this one is that it does take a lot of materials. You have to kind of collect everything up. It takes the students a while to build. Getting the cardboard cut properly so the wheels actually work takes time. And sometimes it works better if you do, extra trials with weight and kind of have kids play with it. So just make sure you set aside a lot of time for this, or find a replacement lab that doesn't take quite so much time, because this one does take up quite a bit of class time. Okay, moving on to Unit 7 here. Our first activity here is a graded lab, Activity 4, and this is just looking at levers. So essentially students are observing the 3 classes of levers using a few different kind of classroom supplies, some really easy stuff. Rulers, pennies, erasers, etc. Not a ton of crazy materials that you have to collect here, but what does get confusing in this lab for the students is all the academic vocabulary. So you're going to need to maybe make sure you review that ahead of time, because that will actually help them, I think, with creating the scenarios for the lab that they have to create, is by kind of understanding a little bit more deeply what each of those words represents. Okay, activity 9, your students are doing a slingshot, and this is a non-graded lab, and it's just looking at elastic potential energy. And so students just need rulers and rubber bands, and it's generally an overall easy lab, but as you can imagine, this one could have behavior issues. So you're going to really want to set a precedent for how it's going to be done, maybe do a demo. It really just depends on the way that your class runs. But one that I maybe also recommend going outside for, maybe like in front of the center, that way you're not doing it in a classroom, having students make sure they wear goggles, all of those safety measures that you can imagine you need to take for high school kids shooting rubber bands. Okay, the next one is activity 13. It's a non-graded lab, and this is a potential and kinetic energy lab. And this one is something that you really have to note, because you're going to need to use mass carts from hopefully a physics lab that you have at a site, or at your site, or at a site near you, because the toy cars that come with it don't roll properly. And so you can't get the lab to work if they're not going to roll. So get some mass carts from the physics labs, and you'll find that this lab actually will work. And you should also have ramps from physics as well. Some of the physical science kits did not initially come with the proper ramp, and so you're going to need to grab one of those from physics and kind of set it up. And you can even also use the slotted masses from the physics class. It's totally up to you. This is a non-graded lab, so you could find a lot of other potential and kinetic energy labs that you could replace it with, or, have students maybe just look at a demonstration on the internet. It's really up to you. But again, just keep in mind all the materials that you'll have to collect. Okay, activity 18. Students are going to be making a thermometer, and this is a graded lab. Students are essentially looking at how temperature scales were created using the thermometer, and it's actually a pretty neat lab. However, it takes a lot of prep. So you're going to need to get a lot of different plastic cups, lids, straws, but then you also need alcohol, food coloring, freezer, hot plate, all of that stuff. So it just gets a little bit tricky with all the materials. This might be a good one to do as a group demo if you have a smaller class. And there's lots of YouTube video alternatives for this. So definitely check out some of the YouTube videos and see maybe if there's ways that you can maybe make it easier for your situation. But again, I think this is an interesting payoff lab that the students do enjoy. So finding maybe a way that you can make a variation on it that makes it work for you would be great. Okay, activity 24, this is non-graded. Students are looking at the Stirling engine. Okay, it is a virtual lab, and you can check out the YouTube link here. Essentially, students are understanding thermodynamics and thermal energy. It's very straightforward, but can be a really difficult concept for students to grasp. So just plan on, spending a lot of time kind of talking through the actual conceptual side of it, and maybe not necessarily how the lab itself goes. This may be one that you could replace for the standard with something else that's maybe a little more applicable to students if you'd rather do that instead. Okay, now we're going to talk about Unit 8 here. Our first activity is Activity 3. This is a graded lab, and students are essentially using Slinkies to look at waves. This is always a really fun one. Of course, the kids love Slinkies. The physics labs came with a ton of Slinkies, so you shouldn't have any problem getting the really good lab grade metal Slinkies for this. And essentially, they're going to look at energy input for transverse, longitudinal, and surface waves by moving the Slinky back and forth. Students really do enjoy this one, but again, this can be a safety one. Make sure you have enough space, make sure that they know what they're doing, give them goggles, things like that. There is a website for part 2 of the lab, so just keep that in mind. This is also actually one that you can find a lot on YouTube with to kind of show students some other aspects of it, or if you're looking to expand on the activity and just do more than what the SAW is calling for. Okay, activity 6. This is another lab about wave properties. This one is non-graded. This is another PhET simulation. So again, as I've mentioned before, you need to make sure that you are using a computer. The Chromebook will not work. So you can do this as a group demo, track down laptops for kids, whatever you need to do. Just keep in mind that while these PhET simulations are really great for showing the phenomena we're looking for, that you just need to make sure that technologically you have things set up. Okay, activity 12. This is a non-graded lab, and this one is looking at wave diffraction. This is another one that is going to kind of take a lot of materials and setup to do. So it requires a tank with water, laser pointers, which came in the physical science kit, stirring rods, tape, pine saw, and the diffraction grading slides. It takes a lot of stuff. This may be one that you're looking to replace, especially if it's a non-graded lab, because there are ways that you can look at wave diffraction in other ways. However, it certainly does have an interesting payoff, and it's good for students to see if you're willing to put in the legwork to help students get this set up and do it as like a group demo. Okay, this next one, activity 14, is looking at constructive and destructive interference. This is a non-graded lab. It's actually another virtual lab, and the purpose is essentially for students to just understand wave interference and what can happen. So you can check out the first part on YouTube, and then the second part is this other link that we have here. Again, since it's non-graded, and if you're having technology problems, you may be able to find some other stuff that you can do in the classroom or some replacement labs for this. It's totally up to you. Okay, activity 18, this is a student favorite. Even though it's a non-graded lab, students really liked kind of hearing all the different instruments and comparing them. So the whole point of this one is to understand the structural differences of various musical instruments and how that creates a different sound. So there's lots of really cool YouTube video links for this. And this is one that you could really expand on. A lot of students seem to have a passion for music. So this can be one of those things that you can kind of build on and use to help get them interested about science, right? Tie the science to the music here. Okay, activity 22, this is a graded lab. This is a reflection lab where students are essentially asked to predict the path of light by studying the angle of reflection. Now, for this one, you're going to need a mirror, a laser pointer, all like the graph paper and stuff. You're going to need clips to stand up the mirror and a protractor to measure the angle. So this one was a little bit tricky for some teachers who did it because they didn't have enough supplies for each group. So they kind of had to do it like one by one. And you could do this one maybe as a demo and use class data or have students look at different angles. It's up to you, but just keep in mind the materials of this one and the setup that is required to do this lab. But this again is another one that has like kind of a good visual payoff for students for them to kind of see what's happening when I point this light at a mirror and what causes this angle and things like that. Okay, Unit 9. For Unit 9, the very first activity actually is a graded lab, and it's essentially giving you an introduction to electricity using some really common, static electricity, things like that. And it's very straightforward, easy, kind of a quick little, show for students. So I wouldn't worry about finding a replacement for this one. You can maybe expand on it if you wanted, if you had a DI setting and you were looking to expand on it. This would be a really easy one to kind of add to. Okay. Activity 7 is our next one. This is a non-graded lab. This one is essentially used to explore electric fields, electric field hockey. And again, keep in mind it is a virtual lab, so all the technology aspects that go along with that. This one's very tricky, actually. I don't think that it's very easy for students to do, but if you have a student that's patient, that really wants to sit there and, try and do it, it definitely works. It's just kind of tricky to get it to work after a while, and sometimes students get frustrated. They're not sure how to do it. So you may want to kind of give them an example ahead of time, maybe kind of make one yourself and then have them do it afterwards. Okay, activity 12, we're creating a 10-cent battery. Now, this is a graded lab, and its purpose is to make a battery using coins. And again, this one's another one that takes a lot of prep and that can be a little tricky for students. So you do need to get the salt water and then collect all the different change. Remind kids, please don't steal my change. I need this for other classes. You do need a little light bulb and alligator clips, which should come with your physical science kit. This one is another one where you may want to look up a YouTube video ahead of time and kind of get some tips and tricks from all the other, kitchen science people that have tried this before. I recommend maybe also doing a demo as well. Students can definitely build them themselves, but it does take a lot, having to go around and help them all if they're not exactly sure how to get it working, because it is very finicky to get it to work. You definitely can get it to work, you just really have to play with it, and sometimes students don't have the patience for that. So it could be a good idea to just keep it as a classroom demo or even as a YouTube video and maybe look at the different ways that people are making their 10-cent batteries and so forth. Okay, in this one we are looking at electric circuits, in this case just the direct current circuits. And you should have all the stuff in the physical science kit that comes with it, the little light bulb, alligator clips, resistors, all that stuff. There should be enough materials for each group to do it, just depending on how many kids you have in the class. And I think the kids enjoy making their own circuit, and this is a little bit more straightforward. You just obviously want to discuss shock hazards, things like that. Make sure you're watching the kids, that they have the proper materials. And other than that, it's a non-graded lab, so you can always switch it with something else, expand on it, go deeper if you're into that, or, watch YouTube videos. It's really up to you. Okay, our last unit here, Unit 10. The first one is Activity 4, which is looking at magnets, and this is a graded lab. And essentially, students are just kind of exploring how magnetic force works, kind of how they explored electricity in Unit 9. This one, they're looking at magnets, and all you're going to need is a bar magnet, some paper clips, tape. Again, another really straightforward one, another one that'd be really great to expand on if you're looking to, add to it or show them different phenomena, use different strength of magnets, whatever you want to do that is really going to help them understand those real basics of magnets. Okay, Activity 12 here. This is a non-graded lab, and essentially what they're doing is they're looking at the relationship between electricity and magnetism. And for this one, you need the iron bolt, the thinly coated copper wire, tape, paper clip, battery, string, clips. It's kind of a lot. And this is another one I recommend for maybe doing as a demo maybe, and then having the students do it afterwards after you've already created it, only because it can be a little bit tricky to get the copper wire wrapped properly, to get it enough, to connect all the clips. It's really up to you, but it's a good payoff because you can kind of see the electricity and magnetism connection. But yeah, just a little bit of setup. It does take time, so just keep that in mind. Now, this is a non-graded lab, so there are, other things that you can do if you wanted to. But this is just one of the easier ways to show it, so just keep that in mind. It is hard to find other ways to demonstrate this phenomena. Okay, Activity 13. This is a non-graded lab. And we're looking at electromagnetism again. So essentially even hopefully a deeper understanding of that relationship between electricity and magnetism. In this one, they're using a compass, copper wire, and batteries to see, if they can create that electric current and then have that create a magnet, which affects the compass. And if you wanted to, I believe, watch a virtual one, here's a link for it here. And then there's also lots of other great labs that you can find that are kind of similar to this, where, magnetism is created or things like that. So this is a good visual payoff for students because it is kind of neat, but it is non-graded. So if it's too much setup for you, the virtual lab or a YouTube video can work as well. Activity 15 and 24. This is a graded lab. It's the two parts, right? So you have it on page 44 and 79. And essentially the purpose is to make a gadget using electric motors. So it is a lot of prep again, and it does take time, which is why it's kind of split into two. They kind of do the initial planning here in Activity 15, and then more of like the building, constructing, things like that in the Activity 24. You just have to make sure you got to collect all the materials, get everything kind of set, just plan enough time for students to do it in the DI class. And it's kind of good to maybe have them do an informal presentation of their gadget instead of the formal video presentation, just for the ease of having, more time to make the motor and things like that. Okay. All right, and that's going to conclude this session of No Sci Science. If you have any questions about these physical science labs, please reach out to your coach, Gianni Polk for OFL, Kira Watkins for OFY, or the science coach supervisor, Alan Andrews, and we'll answer any questions that you can. Other than that, I'm signing off. Thank you.